Hello, welcome back. Let's go on to question 8. All right. Before we start, let's just ignore this top bit here that was from the last questions. I just couldn't I just couldn't capture the textbook without having this in it because of this little y meters over here. So let's just ignore that and let's go on with it. Okay, question 8. The roof of a stadium has the shape given by the function f of x is equal to 20 minus 0.024 x squared for the domain for the x domain -25 to 25. Okay, then they also say the stadium is 75 meters long and its cross-section area is shown at right. All right. So question A, find the volume of the stadium. So find the volume. Now we know volume is given by an area times the height. So let's just draw the length, the 75 meter long length here. Let's just draw that onto the picture. So that is approximately something like that. Those beautiful drawing I got. Yeah, something like that. So this is 75 meters, right? And all we have to do is just find out the area called the cross-section area here, and then multiply by the length, which is 75, and we get the volume of the whole stadium. Rightio. Now, there's two methods to do this. First, and they both works. I just want to show you there's two methods. The first method is we just find out all the area under the curve. Under the curve, with the roof of the stadium, all the area under that. All right, that is probably the most straightforward way to find it out. The second one, right? The second method is we can treat this thing as two part. We can treat the cross-section area as a two part. We can treat it as one part, which is the arc or the half. What they call it. It's not a circle. And the other bit is just a rectangle at the bottom. Right? We know that the rectangle has a height of 5 and a width of, it's called that a width, and we have called that a length then of 50. So we can find out that is just area is equal to 5 times 50, which is 250 meters square area, and then just plus whatever that area is. Right? So I'm going to show you with the first method first, just integrate it. Alright, so we're looking for the area under the curve, so we have to go to integration. So we have to integrate 20 minus 0.024 x squared with respect to x. Right? And now this is not just any, indefinite integrals, because we're given an x domain of -25 to 25. So we have to put that onto the integral sign. So remember, we put the bigger one on the top and a smaller one at the bottom. All right, so this is a definite integral. All right, let's go ahead to integrate that. Now, to do that, that should be fairly easy. So 20 gives you 20x minus 0.024. X squared becomes an x cubed, and they will divide it by the new power. And that's it. There's no c here, be careful, because this is definite integral. So just put 25 and -25 on top there. All right. So let's substitute the value and solve it. So it becomes 20 multiplied by 25 minus 0.024 multiplied by 25 cube all over 3. All right, and then minus the rest of the thing. So it's 20 multiplied by -25 minus 0.024 -25 cube over 3. All right. So let's just solve his side first. So 20 times 25 is just 500 minus 0.024 times 25 to the power of 3. I believe that would give us 375. Let me just type it in the calculator to check. 24 times 25 to the power of 3. Yep, that gave us 375 divided by 3. And that will give us 125. Now on that side is basically the same, but just with different operations, different symbols. So 20 times negative 25 is negative 500. All right. Minus. Now I know when you cube a negative, it still becomes negative, right? Because negative times negative, that's a square, becomes positive. Times itself again, which is a cube, they'll give you negative values. So instead of minus positive 125, this will be minus negative 125, right? So this will give us 375 here, minus, and that will give us negative 375. All right, and then we just plus it together because it's a minus and negative, so that becomes 750 meter square because we're finding the area, right? So that whatever we get must be must be an area unit, and the measure unit is in meter, so the area unit must be in meter square. All right, so area multiplied by height, right? Height, but in this case it's also length equal volume. So 750 times 75 will give us the total volume of the stadium. And let me just do that. 750 times 75. That would be 56,250 meter cube. Yeah, because it's a volume unit. Because this is a meter square times is a meter, give you a meter cube. Okay, so that's that. We can double check with the second method because they both should work. All right, let me change the color. Okay, so we got the area of the rectangle below the arc. So we just have to find out the area of the arc. But all right, so the area of the arc, let's just break it down. Now we know that is f of x, right? But here, this is not y equal to 0. This is not that. Remember, if you look at the graph, that's this line over here, right? It does not have a 0. 0 is more a bit more down there. So this line is actually y equal to 5. Right? So if you want to find the area between these two lines, you have to use the top one minus the bottom one. And then you integrate it. Alright? So you integrate now. So the domain is still 25 to negative 25. That doesn't change. So this is still 25 to negative 25. And now this is your f of x. So f of x is 20 minus 0.024x square. All right. Now minus the bottom function, which is 5, and then integrate with respect to x. All right. Now we can simplify that a bit before we integrate. So 25, 20 minus 5 is just 15. All right. Oops, haven't integrated yet. All right, and now we can integrate. So that would give us 15x minus 0.024. The power increased by 1, divided by the new power. And then, now you see, remember, this is a definite integral. So put our domain over there. And then just do the same thing as we did before. So it's 15 multiplied by 25 minus 0.024 multiplied by 25 cubed all over 3. Then minus 15 multiplied by negative 25 minus 0.024 multiplied by negative 25 cubed all over 3. Now we know that from the previous question, we know that this is just equal to positive 125 and negative 125 here. So let's put it down. Now, by positive, I mean the 125 itself is a positive, but the negative sign comes from the equation. And the same thing here. So there will be negative 125. So all I have to find out is just 15 times 25. 15 times 25 is 375. 375, and this would be negative 375. All right, so that would give us 250 minus, so that is negative 375 plus is 125, that will be negative 250. Alrighty, and now just minus negative, just plus them together, 500 meter square. Now remember, we have, this is not the entire cross-sectional area. We have to plus the rectangle we previously determined, which is 250, right? So total area equal to 500 plus is 250 equal to 750. Now hopefully by now you can see it is the same. So 750 times 75 give us 56,250 meter cube again, right? So that's pretty much question A. I just did double the amount because we just used two different methods. I just want to show you they both work. All right. So so we have to answer the question and find the volume of the stadium. So let's answer the question. So therefore, the volume of the stadium is 56,250 meter cube. All right, that's it. Let's go on question 2. Sorry, B. The stadium is to have several air conditioners strategically placed around it. Each air conditioner can serve a volume of 11,250 meter cube. How many air conditioners are required? Now, this is just a primary school math. It's just the total given volume divided by each of the each air conditioner can service. The volume that each air conditioner can service is 11,250, I believe. And then let's see what we get. 56250 divided by 11250. Oh my God, we got 5 air conditioner. All right, let's answer the question. That was easy. So how many air conditioners are required? So therefore, to service 56,270 meter cube. Oh, sorry, to the stadium. At least 5 air conditioner are required. That's it. That's question B done, and that's pretty much everything done as well. Whew, no sweat. All right, let's take a commercial break and we come back with question 9.